This is the example number 13 we have seen. The 14, 15, 16, they are the variations. This will be given as assignment question. So next is example number 17. Now in this lecture we'll try to cover the three sums. Each will have the logic different from the other. So here example number 17 for the designing of Turing machine. The description of Turing machine is given in a very different manner as compared to other sums. So take a minute, go through the sum, what it says, read it very carefully. It says that let T be a Turing machine which is defined as follows. So these R1, R2, R3, R4, R5, they are representing the rules. Now you should know what each and every tuple means here. This is the 5 tuple listing. Then after giving these rules, for each of the following initial steps determine the final step. When T halts, and it is assumed that T will always begin in the initial position. So now we will start with the interpretation of rule. So we say that or rules have form. Now the very first tuple in the rule will represent current state. Then the second one will represent current input symbol. Third one will represent modified. Either you say modified or tape symbol. Then next step and comes action. So this action will have L or R or N. So if you say R1 is the rule given likewise, so here current state you start is S0, current input symbol is 0, 0 remains 0, so even if the column heading is modified tape symbol, no action is performed, it is copied as it is. So instead of modified, if you want to write tape symbol, you can do so. Next state it is giving is S1, action performed is move to left by 1 cell. This is what is interpreted likewise. So here we will form a table of this and we will include R2 also in one cell blank. So R2 is saying what? 0 is the current state, 1 is the current input symbol which is modified as 0. Next state it is giving is S0 and action taken is move to left by 1 cell. In the similar manner, include R3, R4 and R5. R3 will be start in S0, process capital B, let it be B, go to halt state, and then move to left. R4 is that the processing is been started from it's processing 0 in S1. 0 is modified as 1. Next step is S0. Action taken is move to left by 1 cell. And finally, R5 says that, rule 5 says that in S1, 1 is processed, 1 remains 1, it switches this state to S0, moves to R by 1 cell. So this is how you infer from the given rules. Now using this, if you wish, you can construct the transition table also. Here you find that you got the states S0, S1. Input symbols are 0, 1 and then B. And you also find that halt is also a state. So here you can write S0 में 0 and 1 are processed. When 0 is processed, next state it is giving you S1. 0 remains 0. Action taken is L. From where you got this? S0 में when 0 is processed, it goes to S1. So next state, यहाँ पे अभी what is the format of writing in this cell? The format is comma symbol comma action taken. Format for transition table. In S0, when 1 is processed, it stays in S0. So next state is S0. That 1 is modified to 0. Action taken is go to left. 1 is modified to 0. Stays in S0. Action taken is S. S0 में when B is processed, it goes to halt. Kept as B, move to left. So here, likewise, we are getting the transition table. S0 में क्या हो रहा है? It's S1 में it's processing 0 as well as 1. B is not processed, so that will be marked as dash. When S1 में 0 is processed, it goes to S0. So next state is S0. 0 is modified as 1. Action taken is go to left. S1 में when 1 is processed, it keeps it as 1 only. It goes to S1. It goes to S0. S1 goes to S0. So S0, 1 is kept as it is. Action taken is move to R. This is marked as dash. From halt, nothing is listed. Everything is marked as dash. So from these rules, either you proceed for this processing of ABC or you construct a transition table likewise. Only thing you should remember is that the format of specifying these rules is current state, current input symbol, you get modified or tape symbol, next state, action. So now we need to so we will give the visualization of tape with the A. we give the new visualization of A on input tape. So it is 100 B. 1 1. So we process this leftmost one starting with the initial state. Initial state we consider as S0. So S0 when processes, we will have this as output tape, output on tape, on output tape. So S0 when processes 1, S0 when processes 1 converts it to 0. यहाँ पे है ना, and it stays in S0 by moving towards left. Stays in S0, stays in S0 by moving towards left. यहाँ पे what it will find? It will find obviously B. So what action is taken for this B? Go to halt state. Let B be B. Move to its left. So as soon as it is finding this B, it moves. B is kept as it is, moving to left, and it is in halt state. So tape will be likewise. So this is what you get when you process 110 using these rules. I hope this is understood. We are using R2. S0 is processing 1. It outputs 0. It stays in S0, moves to left. So this is the required answer. For A. For each of the following initial tape, determine final tape when T halts. So halting state we got. Now next is B. Okay, what is the input? 0011 B. So 0011 and then blank. 0011 blank. As always, you start with this leftmost symbol and S0. We will have visual representation of output also, which we consider this to be blank currently. We start processing this leftmost 0 in initial state S0. S0 when processing 0, let us copy this to avoid scrolling up and down every time. So S0 when processing 0, reflects 0 as it is. Moving to left, it's in S1. राइट, इट्स इन S1. S1 के लिए S0 when processing 0 gives you next state as S1. 0 is kept as 0 and it moves to left. Left में what symbol it is finding? Blank. Whether S1 के लिए blank is defined? It's not defined. Whether it is reaching halt state? It's not reaching the halt state. What it says, for each of the following initial steps, determine final step when T halts, assuming T begins in initial position. So it is not ending in halt state, rather it is stuck to S1, and for S1 the rule or transition on blank is not defined. So this is what you get when you process 0011 starting with S0 initial step. Next is third one, 0101 B. 0101 B. Again this will start in the initial state with S0. S0 में it is processing 0. It will reflect the same thing 0. Let us one more time copy this transition table here. S0 में 0 is processed. It reflects it as zeros, moves to left and ends up in S1 step. S1 के लिए transition is defined on blank? No. So here also you will be getting the same thing. Let me check the rules one more time, because for two of them we are getting the same answer, right? At least for third one we should have got the different answer. It's the same, it's given as same. So now modified symbols we have listed here, right? This is the only one symbol. If you consider first, this is the only one symbol which got modified. So rest of the symbols will remain as it is on this tape. So tape will look like modified we have written. The rest of the symbols will be copied as it is, as they are not processed. So this 1 will be reflected here, this 0 will be reflected here. So 1, 0. This will be the output. Rather answer we should write here. This is R. Only 1 is modified to 0. So 1, 2, 4. If you consider this is 6, here you are getting 2. Again, in this case, this 0 is kept as it is, and this 0, 1, 1. But whether it is in halt state, no. You will say stuck in S1 state. Whereas in this, again you will find that this 0 as it is, and this is also 1, 0, 1. कहाँ से आया? This only got processed and it is moving to left. Rest of the symbols will stay same. So here also it is stuck in S1. So the solution begins with interpretation of rules, construction of transition table, and then processing of the given strings. Give the visualization of output on tape after processing ends. This was the sum number 17. Next, with some different logic, 18. Let me copy the sum. It says that you need to design the right shifting